Welcome to the Enterprise Sessions. Today, I'm talking to Professor Anthony Laing. He's Professor of Physics and also co-founder and CEO of Duality. Welcome, Anthony. Thank you very much indeed for finding time to talk to me. So I'm looking forward to talking about your research, which I already know is going to be fascinating. I'm also looking forward to finding out more about Duality. But before we start with those, maybe you could tell us a little bit about yourself and what brought you to the University of Bristol.
Sure. Thanks, Michelle. Thanks for having me on the Enterprise Sessions. So I've always been at Bristol. I came to Bristol as an undergraduate and did my PhD here and stayed here as a postdoc and then a fellow. But I came to Bristol in 2001 as a mature student, so I was 25. I didn't have A-levels in maths or physics, but I was accepted onto a foundation year. It's actually called a preliminary year, but it's kind of a foundation year. Mm-hmm. And it's kind of 2 years of maths and physics A-levels all kind of squashed into one. So I did that as a kind of precursor to the main undergraduate course, which was actually astrophysics, so not quantum at that time. But I guess my kind of connection to physics, although the thing that really inspired me to come to Bristol was I think I watched those documentaries, the old Equinox documentaries about kind of the universe, and I just wanted to understand the universe, and that was really all I had in my head. I just wanted to understand how kind of time works, and is time travel really a thing, and that kind of thing. So
just the small questions, yeah.
That was it's probably the movies, I think, Back to the Future and things like this that really pushed the button in me. So, but I wanted to get deeper and really sort of, understand whether this stuff, is it, how true, how close to the reality is what we saw in Back to the Future.
There's so much said in the press and on the internet, on Twitter, about what quantum computing could achieve. But I'm really conscious that a lot of it is probably pretty fanciful or certainly a long way off. So what is the end game? Why are we trying to do this?
So there are a handful of kind of well-formed application areas where we know that if we can build a quantum computer, then we can gain an exponential time advantage over even supercomputers.
Okay.
Quantum factoring is one of them. But finding kind of special states of molecules, what's called, eigenstates of molecules, that's another one. And if we can do that, if we can solve those kinds of problems, then we can, we can improve drug design. Okay. We can design better materials, this kind of thing. There's still some work to be done in connecting those kinds of mathematical solutions to sort of real world problems.
But this is, if I've understood you, about taking things versus drug design and material sort of developments, less from a laboratory setting and more into a sort of computational setting, such that we can compute what it is we need to do, and then the drug can be made, the material can be made, but that it takes the experimental aspect of that out or reduces it.
I think there are various stages to drug discovery,
and
you'll still have to do clinical trials and those kinds of things, and then the screening steps. But the modeling bit could sort of really have could really significantly reduce the time between, I guess, conception and ultimate drug discovery. So February 2020, incorporated the company, a big moment. And we also won an Innovate UK project.
Fantastic.
Part of an Innovate UK project. And so that was brilliant.
And what did that permit you to do, that Innovate UK funding? Was that, because obviously there's different types of grants and awards and loans that they make, was that around the sort of the laboratory facilities, the design, the fabrication? Was that more about getting the people in? What did that permit you to do that you couldn't have done beforehand?
That particular Innovate UK project was led by a company called Riverlane in Cambridge. They're a quantum software company. And at the time, what they wanted to do was to show that they could develop an operating system that could sit across different hardware platforms. So, of course, in addition to photonics, there are other ways to build a quantum computer: ion traps, superconducting qubits, which is what Google and IBM pursue.
Yes, that's the one you often hear about in the press, isn't it? Yeah.
And so that's what that project was about. So it was kind of developing hardware and connecting that to the operating system that Riverlane were developing. It also kind of pulled us into the community, which was great, and kind of got us going. We also needed to match fund that project, and in March 2020, the world very quickly changed into something that we just weren't expecting. There was the pandemic, there were lockdowns, there was a feeling of chaos, and at that point, the investors that we were speaking to weren't investing anymore.
I'm not sure anyone was investing in March 2020. Certainly, everything just sort of stopped, didn't it? So. But if your Innovate funding is predicated on match, that's a bit problematic when the investors suddenly just stop talking.
I think we had a good reputation, and we still had the facilities to make chips. We still could design chips, but we just couldn't scale in the way that we wanted to. We were speaking to British Telecom at the time, who were leading a different Innovate UK project. And they wanted a particular kind of quantum photonic device developing. So this wasn't quantum computing, this was kind of quantum authentication.
Okay, so for secure data transfer, for
if two parties want to authenticate one another, they wanted a kind of a quantum solution to that problem. So that's what we did for British Telecom. And it was one of those situations where that hiccup, although it was an uncomfortable sort of few weeks and months, in the end was one of the kind of really kind of made us, because we won that contract with British Telecom. We then had to get commercial really quickly. So we had to
deliver. Now you got the contract.
We had to deliver that. So we had to do things like insurance. We had to get like a formal leasing arrangement with Southampton and Bristol.
Yes, as opposed to going in straight into sort of investment backing, which sounds from your story like it might have been the first plan. That plan had to be revised, as plans so often do. Getting the contract must have forced you into a position you hadn't anticipated. But did it ultimately serve you well, do you think?
The original plan was, get a pile of investment, and then build a quantum computer or some version of a special purpose quantum computer, do manufacturing in Southampton, design the devices and test them in Bristol, and just kind of scale it up, the same as sort of most of the other quantum startups were doing. With the building a quantum computer and so on, at some point you still need to get commercial. You need to have customers, right? You need to build a thing that people want to buy, either time on your quantum computer, or you need to be able to ship them quantum computers. In the end, you have to have a product. Yeah. We ended up, we started with a product, right? We just very quickly had to find a product that we could develop for that BT would
wants to buy, pay money for.
So we thought, okay, you know what, we can start producing products kind of now. But then what you have to be able to do is still stay on your main technology roadmap, and somehow find a way to commercialize that kind of earlier on. So in the early days, that's really what we were doing. And we won, a few other contracts as well. So the National Quantum Computing Centre, the UK Atomic Energy Agency got in touch with us and asked us to solve a particular problem. And then we were producing chips in Southampton, and we started to sell some of those chips kind of abroad.
So where is Duality now? You set this up a little over 3 years ago.
Yeah.
So what have you reached, and is it where you hoped you'd be now?
Yeah, it is where I hoped it would be now. It's not exactly where I might have predicted. We're more commercial now than I thought we would be. We're exporting chips. We've got several customers. We arrived at an application that we wouldn't have arrived at unless the UK Atomic Energy Agency got in touch with us and presented us with a particular problem. And so that was maybe a clue as to how quantum computing might need to work in the future. You might need to
customer driven, effectively.
That's right. We need market traction. So there needs to be a pull there. And so UK AEA, they are developing fusion reactors, so nuclear fusion, clean energy. And actually, just to sort of, I guess, digress for a second, there were some people that approached us, some companies that we didn't do business with, or that I was about to do business with. So kind of oil and gas companies that maybe are related to kind of defense. And there was a reaction in the company. So the young people that we'd hired were not keen on those kinds of partners. And, and I guess I kind of said, well, look, on this oil and gas company, they want to go in the renewables direction, and we can help them do that. We can show them, we can simulate how to design cleaner fuels, and they just weren't having any of it.
No.
So I could have just, put my foot down and said, look, this, you got to get real, guys. But I didn't want to do that. I thought, well, it's one of those situations, another situation where if you just listen to the world, it's telling you a particular thing. And I wanted the company to be distinctive and have a voice that was different from the other companies. And that really meant, I think, listening to that team, those first 10 people are really key. Not just their skills, but also kind of their beliefs.
Yeah, their values.
So I thought, okay, well, that is the company now, right? The company's not just me. It's not what I say it is. It's what it really is. So although we turned down some opportunities, on the flip side, when the UK AEA got in touch and said, well, what we're trying to do is build fusion reactors, and nuclear fusion is where you take hydrogen or isotopes of hydrogen, you squash them together to make helium, and you get energy out. It's actually much harder than that, but that's the basic.
As a principle, yeah.
But it's it's clean energy, and it's renewable, and it's it would be the biggest building block in the solution to net zero if we're able to pull that off.
It's fascinating, the things that can emerge from these journeys, isn't it? Because what would you like your legacy to be is a question I try to ask as part of these interviews. But it's fascinating to find one where the legacy that you would now look to have is one that had really nothing to do with it when you set out. And it's that emergent opportunity, which maybe is that part of that entrepreneurial spirit, is not just ploughing the furrow that you set out to, but being open to the opportunities that emerge as you progress.
Absolutely. If you think of my journey, I wanted to do astrophysics. And then I heard about quantum non-locality and changed to quantum, but the foundations of quantum.
One lecture had your career pivot in a direction
Absolutely.
that you couldn't have anticipated.
And then I saw how kind of that foundations training can really kind of connect to quantum technologies and change the game. Did an experiment in kind of, what you might call traditional quantum computing, in which we, factored a semi-prime number, but then again went in a different direction, in the direction of special purpose quantum computing. Couldn't quite see how to scale it up until we saw that there was a material that just emerged that was very interesting, and was an opportunity to do manufacturing in the UK and create jobs, nanofabrication jobs, high skilled, not metal bashing, but economic game changing results. But still, we're still in that direction of simulating molecules. Really was what we were thinking of. But then connected with very interesting people, different scientists to us, very smart, very creative, from the UK AEA, and that's a market now, right? So now we've got market pull. So in terms of legacy, of course, if we can be part of the story that's solving climate change, then that would be magnificent. On a more sort of down-to-earth scale, I think just if we build a great company with great people who are very passionate, who want to solve important problems, and if we create jobs, I think if we have a great relationship with the universities that the kind of the founders are from, if we can show that can really work, that kind of partnership between academia and industry, then that would be a great legacy. And I think probably the way to do it isn't to sort of go and ask permission and say, we've got this idea and we think it's going to, it might be a bit tricky to pull off, and then try and get approval for that, which, it would never happen or it would take too long, just to show that it can happen. And then, and if it is a big enough success, I think the universities and investors will just want to be part of that story, and we'll back it.
That's all for this enterprise session. But join us again soon to hear more about the way our amazing staff and students are translating their enterprising ideas into real-world impact. And do please click on the links if you'd like to contact the University of Bristol.